Guys, welcome to another math lesson. This is lesson 1 for week 6. Our number starter for today is about composite numbers, which are numbers which have more than 2 factors. Which of these numbers below are composite numbers? You can send me a message with the answer. Our learning intention for today is to describe the properties of square and triangular numbers. Your success criteria will be I know what a square number is, I know what a triangular number is, and I can solve square and triangular number equations. To recap, what are square numbers and what does 3 to the power of 2 mean? That's what that little 2 means. It means to the power of 2. Who can remember what that means? Let's have a look. So a square number is the product of a number when it's multiplied by itself. So if we have 3 to the power of 2, which is 3 squared, this means 3 times 3. So 3 times by itself, 3. The product of 3 times 3 is 9. 9 is a square number, okay? There are 12 square numbers you already know from your 1 to 12 times tables. So 1 squared, or 1 times 1, which is 2, so 2 is the squared number. 2 times 2, or 2 to the power of 2, which is 4. 3 to the power of 2, or 3 times 3, which is 9. 4 squared, or 4 times 4, which is 16. 5 squared, or 5 times 5, which is 20. And you get the gist. The other squared numbers are 36, 49, 64, 81, 100, 121, and 144. Today we're going to learn about triangular numbers as well and look at different ways of representing square and triangular numbers. Square numbers can be represented by drawing a square array. The number of rows must be the same as the number of columns, because otherwise it's not a square, right? So here are the first 5 square numbers drawn into square arrays. You can see that 1, it has just 1. 4 is 2 rows of 2, or 2 columns of 2. And then altogether there are 4 circles, so the answer is, so 4 is a square number. 9 has 3 rows of 3, or 9 dots altogether. 16 has 4 rows of 4, and 25 has 5 rows of 5. We can also draw square numbers as squares, with each small square representing 1. So here are the first 4 square numbers drawn into squares, and you can see that each small square represents 1. So again, for 1, we've got 1 square. For 4, we've got 2 rows of 4, or 2 columns of 4, and so on. This is where you can find all the square numbers up to 12 times 12 on a multiplication square. You can see that you can find them quite easily going down diagonally across the multiplication square. Triangular numbers are numbers which we can represent with dots to make an equilateral triangle. And remember that an equilateral triangle has an equal number, the sides are all equal, okay? So they're all going to be the same length, or all represented by the same number. So the first triangular number is 1, and it's represented by 1 dot. The second triangular number is 3, and it's represented by 3 dots, and the number of dots on each side of the triangle is just 1. 6 is the third triangular number, and it's represented with 3 dots on each side of the triangle. Then we've got 10, which is the fourth triangular number, and we've got 15, which is the fifth triangular number. As you can see, each time the number of dots on one side of the triangle increases by 1. The first 10 triangular numbers are 1, 3, 6, 10, 15, 21, 28, 36, 45, and 55. And you can see that there's the same number of circles along each side of each individual triangle, and that's because they're equilateral. So you can see how triangular numbers are built through a sequence by looking at kind of a number sentence that makes up the triangular number. 1 is just made up of 1, obviously, but then it gets interesting when we start making 3. So we make our 3 triangle, and we can make it by adding 1 plus 2 more dots. Okay, so 1 being the first triangular number in the green dot, and then 2 being the 2 purple dots that we've added. Then we take that again and we add 3 to make 6. And let's see how we're just adding another row on the side there in the orange to build our triangle. It's still an equilateral triangle because there's the same number of dots on each side, but it's but we've added the next number on. Then after 6, we take that, so we've added 1 plus 2 plus 3, and this time we're going to add 4. And if you add those all together, that makes 10. So we've got 10 dots all together. The next triangular number is made by adding 1 plus 2 plus 3 plus 4 plus 5, and that's 15. I'm not sure if that picture actually matches. The next triangular number is 21, which we can make by adding 1 plus 2 plus 3 plus 4 plus 5 plus 6. So you're starting to see a bit of a pattern here. Then 28 is made by adding 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7. And then we can keep going on and on and on with our triangular numbers to find the next one and then the next one. Let's have a look at some of these examples. Is 18 a square number because it is even? Well, first of all, it doesn't matter if a number is odd or even when we think about square numbers, okay? Whether it's odd or even has no bearing on the answer, on if it's a square or not. If we're thinking about is a number a square number, we need to check its factors and to see if there is a number when multiplied by itself that we can that would make it a square number. So the factors of 18 are 1 and 18, 2 and 9, 3 and 6, and that's it. So 18 doesn't have any factors that when multiplied by itself makes a square number, so it's not a square number and it doesn't matter if it's even. As we can see here as well, it doesn't make a square when we draw it out into an array. There's no way we can arrange 18 dots into a square, so it is not a square number. Is 36 a triangular number? Well, we would need to check our list of triangular numbers, I would say, and see if we can draw an equilateral triangle with 36 dots and see if it would fit it into our sum. I think you would just need to know the first 10 to know if it was a triangular number or not, and I think it is. Yeah. It's actually really unique because it's also a square number as well, because we can times 6 by 6 to make it a square number, 36, and 36 is a triangular number as well because we can make it by adding 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8. What square numbers are represented here? You can just figure out what square numbers are represented here by just counting one of the rows or one of the columns. You can quite easily see that they are squares, so they're definitely going to make one of our square numbers. For the first one, I think that's 10. There's 10 across the top row there, so 10 times 10 would be 100. There are 100 little squares there, so that square number is 100. The next one down, there's 4 in each row, so 4 times 4 is 16, so that one, the second one is 16. And then in the last one, there is 7 in that top row, so 7 times 7 is 49. Is 46 a square number because 23 plus 23 is 46? It does not matter if we can half the number and that makes it a square. That doesn't count at all, okay? 46 is not a square number because it has no factors that we can times by themselves to make 46, okay? 23 is a factor of 46, but 2 and 23 make 46, okay? So it does not matter. We can't tell whether it's a square number just by adding those halves together. Is 5 a triangular number because 2 plus 3 equals 5? Well, yes, 2 plus 3 equals 5. 5 is not a triangular number because it doesn't follow that sequence of 1 plus 2 plus 3 plus 4 plus 5 and so on and so forth. You know that 6 is a triangular number because 1 plus 2 plus 3 is 6. 5 is not a triangular number just because 2 plus 3 equals 5. Our learning intention for today has been to describe the properties of square and triangular numbers. You should now know what a square number is, and you should now know what a triangular number is. Hopefully that you can go and solve some square and triangular number equations now. Unfortunately, a lot of this you do have to just kind of know by heart though, or at least know the sequence to figuring out what the next one is. If you would like to challenge yourself, have a look into pentagonal numbers, okay? A bit like triangular numbers, but we make a triangle out of, a pentagon out of them. You've only got one quest to do today, guys, and it's to do with square and triangular numbers. It's the same for everybody. Hopefully it won't take you too long. Thanks, bye.